Right now I have the voltmeter set to a very large scale. This means its readings aren't very sensitive. When I connect the voltmeter leads to point 1 and point 4 along the length of the wire, it's showing a reading of 0 volts. If I change this to a more sensitive scale, it's now on the 200 millivolt scale, and I connect to the same points. It's giving us a reading of 20.7 millivolts. This tells us that the electrons are actually losing a very small amount of energy as they pass through this wire. Even though this wire is made out of copper, a metal with low resistance, the resistance isn't zero. And so a small quantity of energy is lost by the group of electrons as they travel along this wire. In many cases, this amount of energy is very small, and so we will make a reasonable assumption that the amount is equal to 0, and we will call that our ideal wire assumption. So under this assumption, our wires have no resistance, and the group of electrons will lose no energy as they travel the wire's length. In many cases, this is a very reasonable assumption, unless we have to make very sensitive and precise measurements.